Hi, it's Eric Hartman with the Choroideremia Research Foundation, and I am very honored to be here with Dr. Kapil Bharti from the National Eye Institute. Dr. Bharti is on our Science Advisory Board. He's a member of our International Choroideremia Research Network. And Doctor, you've been working with David Gamm, a collaborator of yours and certainly one of our researchers. And you presented today some of your research on transplanting just the RPE, and obviously with CHMers, we will need both the photoreceptors and the RPE. But one of the things that I found interesting first today was that you mentioned that the transplanted RPE will actually help form the new Brooks membrane. Is that correct?
Yes, so first of all, Eric, I must say it's a wonderful pleasure to see you and meet you in Iceland, of all the places. And yes, to answer your question,
Yes.
the RPE-only transplant will form a Brooks membrane on the scaffold that we put the cells on, and the cells make their own extracellular matrix, the scaffold degrades, and only the cellular proteins are left, which looks like Brooks membrane. We've done enough characterization of this material, and we know it does behave and looks like Brooks membrane.
Now, the scaffolding that you're using, is that a permanent scaffolding, or will that biodegrade over time?
So it's a biodegradable material, you're right, and it takes about 8 to 10 weeks for it to degrade completely. We put the cells on it outside in a dish, and that process, cells mature on it for about 4 to 5 weeks. So half of the material is already degraded when we transplant in the eyes of patients, and the rest of it degrades within the first month.
One of the things that for choroideremia patients is we will need both the RPE and the photoreceptors. And I know that David Gamm is working on a certain type of grid, and that allows the photoreceptors to come from underneath the RPE and attach within, a sheet. The question is, what would happen, because I know there's a huge function with the muloglial and microglial in the health and sustaining of photoreceptors.
Mm-hmm.
Do you have any studies or work that's underway now to see whether or not the muloglial will reorient to transplanted photoreceptors and are those the microglial or muloglial, are they giving vertical structure and insulation in between the photoreceptors?
Yeah, so excellent point. So I think the work that David Gamm is doing with us is where he has this another type of scaffold called honeycomb scaffold, where we see, so it's really structures of honeycomb plastic material which slowly degrades, and we seed RP at the bottom of those wells, and then we put in top photoreceptors. And so far it's looking fantastic. We actually just got material from him last week to test in pig models. And to answer your question, this is exactly what we're going to be looking for once we transplant in our laser model, which, as I showed today, is very similar to what happens in AMD eyes, is that the RP is gone, the photoreceptors are dying, but rest of the retina is still intact. And also, I would say in choroideremia eyes, it's what happens is rest of the retina is still intact. So the Muller glia cells are still there, and we're hoping as soon as they see the new host photoreceptors coming in, they will come and talk to them, provide the vertical pillars that you're talking about, support the health and functioning of those photoreceptors.
Well, and you talk about the model that you're currently using requires they use a laser to basically kill the RPE, correct?
Yes.
So it's a damaged retina. But in the case of what we're working on, and you have been involved with, is creating a CHM pig model, which would then give you potentially a very powerful tool for research. And what are your thoughts on the investment that we're making in creating the porcine pig model?
So you're absolutely right, Eric. The laser model, the way it's designed, it first ablates the RPE, and then the retina starts to die. But that is not exactly how choroideremia happens. We see in choroideremia damage in the choroid and the RPE, hence called choroideremia, and we see then degeneration of the retina. So really, I think that pig model that we're trying to make will be an invaluable tool that actually a foundation is funding. I think is a fantastic support that they provided. Will create a tool that will allow us to not only test actually iPS cells from choroidemia patients, iPS-derived RPE and choroid and photoreceptors from choroidemia patients. But we also have then the possibility of testing the pig iPSC derived from, because from the same pig that we have made the choroidemia model, we have the cells left from which we have now made iPS cells. That will allow us to follow long-term integration and survival, because now it's pig cells in pig and not human cells in pig. So we'll test in parallel human and pig cells and see how the pig cells can survive long term. We see integration of RPE, integration of the photoreceptors, and then at the same time we bring and test our human cells so that we know human cells are functioning as well. When we go to patients, we have data from both of them. So I think this is a fantastic tool that, and not just us, we will be testing it for cell therapists, but I think the community that is trying to develop gene therapy for choroidemia, this tool will be extremely valuable for that community as well.
Well, I think we're all very, very hopeful, and it's a big investment, but I think it's one that's needed. And if we as a foundation can get ourselves with a pig model early on, it just helps advance us, and as they say, getting us to the head of the line at the bus. You know, if we're there,
Absolutely.
It gets us our foot in the door with many different potential trials.
Yes.
Well, I am so sorry you're not going to make our conference in Rochester. I'll be leaving here and going to Rochester, but you have another conference to go to also.
Yes.
Well, again, thank you very much for all your time, and I look to see you again. It was so great to see you here in Reykjavik.
Likewise, Eric, and I'll be there at your conference with my mind. Physically, I won't be there, but I'll be present with my mind, and I know friends and colleagues are going to be there. I'll be talking to them and working with them, as you know, closely.
Sure.
So enjoy the conference, and it was wonderful to see you.
That was great. Well, that's about it. We have a little bit more left here on this last day of the Retina International World Congress and the Nordic Ophthalmology Congress. So if I can get a little more time in, I'll get you another update. But that's it for now from Reykjavik, Iceland.
Thank you.
Thank you.
Thank you, Salami.